Okay, this is the first lesson on Python. Had to prepare a wonderful video with also my face here, but the stupid Mac didn't record my voice, so after 1 hour of video. Okay, let's restart, this time without my face. So, this is Jupyter. We have already seen Anaconda and Jupyter, so you are pretty familiar. Let's see, we'll start now writing Python programs. Python is an interpreted language. Interpreted. Okay, programming language can be interpreted or compiled. And there is a big difference between the two. Compiled languages are languages that you must write completely, so you must write a complete program, check that it's syntactically correct, and only when it is syntactically correct you use the compiler and you convert the program to a machine program, a sort of app. The app that you have on your smartphone and also the programs that you use on your computer are compiled. So you have already a machine program which you cannot touch, you cannot do anything with that, you cannot change it. You cannot change it on an app from your smartphone. Those are compiled programs. Compiled programs are much more efficient, okay, but they're not very convenient if you want to continuously do little modifications to them. Interpreted programs, on the other hand, are programs that you write. Let's see, for example, this one you write, and then you call the interpreter, in this case Anaconda, which will execute the program line by line and stop whenever it finds a syntax error. Okay, so are much more versatile, much more convenient in case you have to continuously modify them and you are not looking for immediate performance. Okay, so Python is an interpreted language. So whatever we will write, we will call the interpreter, which on Anaconda means simply pressing Shift Enter, and the program will be interpreted by the computer somehow. Okay, write a Python program that prints how many minutes there are in a week. So, print. In a week there are 7 days, you should know. By how many minutes? 60. Sorry, each day 24 hours. By 60 minutes. And this is our first Python program. Please note that this works only for Python02. I am using Python02 currently. If anyone has Python03, you must use the parentheses for print. This is the first. You will see in this lesson two main differences between Python2 and Python3, which are basically almost the only two differences. There are few others, but minor. Okay, so I will write it in this way, or I can write it in the Python2 version. Okay, Shift Enter, result. Okay, this is our first Python program. You can write whatever you want after print, any mathematical calculation. Okay, you can put also parentheses. You know that what I'm doing now is very different with or without parentheses. As many parentheses as you wish. Also these useless parentheses here. Provided obviously that they are coupled correctly. Okay. An interesting thing that we will see immediately is this one. Oops. Python is case sensitive, so writing print in this way or writing print in this way, it's very different. Print. Look, this is a famous example. What the result should be 5 divided by 2. Well, 2.5, right? 2. Why? Well, because Python version 2 has the following belief. Since I'm using here an integer and here an integer, well, probably I want to see as a result an integer. So distinguishes strictly between integer and float. Even though usually a division leads to a decimal number, which in Python is called float. In Python 3 this problem doesn't exist. If you type print 5 divided by 2, you get 2.5. So how to get 2.5 also in Python 2? Well, you write it like this. 5 dot means 5 dot, it's an abbreviation for 5 dot, an infinite amount of zeros, which means that 5 now it's a decimal number. So I have a decimal number in the middle, so Python say, well, probably he would like to see the results in decimal number. In fact, 2.5. Okay, so this is the second difference between Python 2 and Python 3. Okay, now that we have seen this first very little program, let's see the Bakus-Naur form. What the hell is this Bakus-Naur? So John Bakus. Oh, this is John Bakus. Okay, let's see. He died in 2007, so he has never seen a smartphone. Well, let's see. John Bakus is one of the inventors of Python, one of the first programming language. We have here an historical picture of him. Okay, if you are complaining that your screen is too small, look at the so-called screen of John Bakus. Okay, together with Peter now, which looks much more like a crazy computer scientist than John Bakus. Can you see? This is Peter now. This really looks like a crazy computer scientist. Let's see. Do we have pictures of him when he was young? No, we don't. Oh yes, here. With a typewriting machine and a tape recorder. Okay. They invented this form. It's a sort of way to write the programming grammar. Each programming language has its own grammar, exactly like a standard language. The main difference, however, is that the language of the grammar of the standard language is full of exceptions, especially English, but also strong grammatic languages such as German are full of exceptions, and sometimes it's not so strong. So if you made a mistake during spoken English, nobody will point it out, I hope. A little grammar mistake. On the other hand, the grammar of programming language doesn't have any exception, and it's very strong. You cannot make mistakes. Okay, the Bakus-Naur is a form of writing grammars. Let's see a grammar for English. So this is the Bakus-Naur notation, BNF, Bakus-Naur form notation, for a grammar in English. So we write it like this. Sentence can be a noun, a verb, and a noun. So noun followed by verb followed by noun. This means it can be. But it means it doesn't mean it is, because it have different values. What is a noun? Well, a noun can be I, a noun can be you, a noun can be apple, bird, cat. A verb, what is a verb? A verb can be eat and a verb can be like. In this way I have defined a sort of micro English grammar, so a very limited English grammar, with only 5 nouns, 2 verbs, and only one type of sentence. All the sentences must be written like this. These are called non-final items, and these are the final items. So everything enclosed by these symbols here, it's a non-final. It means that it must be further specified. Okay. So look at these sentences here. Do they respect the grammar? The grammar specified here, obviously. Well, let's see. Oh, are these sentences? I eat apple. So I, which is a noun, eat, which is a verb, and apple, which is a noun. Fine, it's a sentence, it respects. Bird eats apple. Bird is a noun, eat is a verb, and apple is a noun. It respects the grammar. Notice that this does not respect the English grammar, but it respects my own little grammar here. Elephant eat apple. Elephant is not a noun. I know that in English elephant is a noun, but not in my grammar here. So it's not a sentence, it's something, a computer will give you syntax error here. Syntax error, elephant not defined. Cat like bird, cat is a noun, like is a verb, and bird is a noun. Okay, I like cat eat you. I know that you would have preferred you eat cat, but no, it's a cat which eats you. Cat is a noun, eat is a verb, and you is a noun. I like you, same thing. And I like it. Let's see this one. I is a noun, like is a verb, and it is present in the grammar, but as a verb, not as a noun. So it's not, this is noun, verb, verb, which is not allowed. So it's not a sentence. If I had written also something like this, now I like it would have been allowed. Also I like would have been allowed. And also I eat it would have been allowed. Okay. Now let's switch to computer, particular to Python. What we have written here? Look, we have here the print statement, print. Then in Python 3 you have the parentheses, in Python 2 we don't. Then we have this thing here. This thing here, look, it's a mixture of numbers with some operators in the middle and with parentheses. This thing here in computer science is called expression, but also in mathematics it's called expression, by the way. Okay, so let's see how can we formalize the grammar for this instruction. Statement. So this thing here, it's a statement. Each line of Python is called a statement. In Python, each line is a different statement. Not an instruction, statement. It's made of print followed by an expression. This is a non-terminal symbol. It will be means that it will be further defined. This is for Python 2. For Python 3, print, open parenthesis, expression, close parenthesis. What is an expression? Well, an expression could be a number or an expression, operator expression. So an expression can be composed of other expressions. What is an operator and what is a number now? An operator can be plus or multiplication. It could be also division or subtraction, but to make things easier, I will stick with plus and multiplication. A number could be, in this little grammar example, any integer positive number or any integer negative number. I don't know why I repeat 0, but it doesn't matter. Okay. This comma is because I'm lazy. I should have written all of them. But if we stop here, we are not including parentheses. So parentheses don't exist. This parentheses here I'm talking about. This kind of parentheses here. So we have to further specify that an expression can be made of parentheses, expression, close parentheses. So there could be parentheses enclosing expression, and it's still an expression. Okay. So as you can see, the grammar is very strict. It doesn't take anything for granted. Must specify clearly everything. Let's see here these things here, whether they are compliant with the grammar. Some of them may be good Python statement anyway, but let's see whether they're compliant with this grammar here. So print 3. So we have print, then 3. 3 is a number. 3 is a number, which is an expression. So print expression. Fine. This is compliant. Print, open parenthesis, 3, close only one parenthesis. So print, this thing, we have to check whether this thing here is an expression. Okay, so 3 is a number, which is an expression also. 3 between parentheses is an expression, but this thing here is not an expression, because can you see the expression must be closed by 2 parentheses. So this is nothing wrong. This thing here, is this thing an expression? Well, 3 and 4 are numbers, which means there are also expressions. 3 plus 4 is expression, operator, expression, which is an expression. The parenthesis of an expression is an expression. An expression multiplied by another one is still an expression. The parenthesis of an expression is an expression. An expression multiplied by another is still an expression. And the parenthesis of an expression is still an expression. Print followed by an expression is a statement. So as you can see, it's very, very formal, but very, very strict. Let's see here. Print plus 3, 3. This is print followed by an operator, a number or expression, then a space, and then another number of expression. Is this allowed? Operator, expression, expression, or operator, number, number? No, I don't see it. There is expression, operator, expression, but you are not allowed to do something like this, operator, expression, and then another expression. This is not allowed at all. So this will give you a syntax error. Okay, and this is also an expression I hope you have understood. So this is the Bakus-Naur form. I will write many times, whenever we introduce a new thing, I will write its syntax in this way. So you have the thing you have to remember is that anything between this symbol is a non-final symbol. It means that it must be further specified. You don't have to use it literally. Everything not enclosed by this symbol, such as this one, but also this one, must be used literally. So you must use exactly the thing. Okay. Now let's go back to Python code. Let me check whether it's recording. Write Python code to print how many centimeters light travels in 1 nanosecond. And you say, what? Now, I am sure that you believe that when you finish high school and started studying economics, you say, okay, now I'm over with physics. You were wrong. Okay, let's see. I want to know how many centimeters the light travels in 1 nanosecond. Do you know that the speed of light is not infinity? Don't you? Okay, otherwise I will send you back to high school. Okay, let's see the speed of light. Speed of light. Hop. Here it is. It's in meter per second. Okay, whenever you take something, you take a number from the web, whatever number, especially economical number, checking which unit of measure is it. Because sometimes it's million euros, sometimes it's in $1,000, makes it different. Copy. Oh, there is also meter per. Oh, look, it's perfect here. Miles per hour, kilometer per hour, parsec per year. Okay. Okay, so print. So this is the speed in meters per second. Okay, but it's in meter per second. Do you know that 1 centimeter it's 1 meter divided by 100? Don't you? Otherwise I will send you back to elementary school. Because I clearly remember having done it at the 3rd class of elementary school. Still have my handbook. So I have to multiply it by 100. And I will get the speed in centimeters per second. But I don't want to know how many centimeters light travels in 1 second, which is too much. I want to know how many centimeters light travels in 1 nanosecond. So, since 1 nanosecond is 1 second divided by 1 billion, I have to divide by 1 billion. Please note, no spaces here. Because, why no spaces? Why can't I write it like this? Because look above. Do I say that you can write numbers with spaces? No, I don't say that you can write. I don't say number is equal to 1 space 0, 0. No. You can. I don't say that you can write numbers with spaces, so you can't. Okay, result 29. Is it correct? Well, look. Do it by hand. Otherwise, I'll send you back to middle school. Look, this one by 100 divided by 1 billion. You simplify it to zeros. So it must be something like 29.97. But you get 29. Why? Because I'm using Python02. The usual problem. Tac. If you're using Python3, you will get the right result. Now? Okay. So tell Python02 that you want... one of the numbers is a number with commas. So like this, for example. And now you get the right result. I'm not enough. Print how many centimeters. So 29 is more or less a sheet of paper. Print how many in one nanosecond. How many centimeters light travels in one of your own computer cycle. What the fuck is a computer cycle? Well, your computer processor has cycles, so does little operations. So, little binary operations, such as 1 plus 0, which results in 1, or 0 plus 0, which results in 0, or 1 plus 1, which results in not 2, because it's a binary operation, results in 1, 0. Okay, these little binary operations are done in one cycle. How do you get your processor cycle speed? Well, on the Mac, it's here. 1.3 GHz. On Windows I system about. So, print So I have to get, first of all, the speed of light. Okay. I want to know in centimeters, so by 100. Divided by. Now it's not in 1 nanosecond, but it's in 1 cycle. I have 1.3 gigacycles per second. So divided by, open parenthesis, 1.3 by, it's a gigacycle, so 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, this is the amount of cycles that my computer does in 1 second. Not too many, by the way. Oh, and the light travels 23, approximately my hand, with spread fingers, 23 centimeters in 1 cycle. So while my computer says that 1 plus 1 does not make 2 but makes 1 0, the light has traveled my hand. Okay. Okay. Oh, I'm sorry to announce you that we are over with physics. Okay. Variables. As you can see, sometimes you use numbers continuously, for example this one or this one. It may be convenient to store them somewhere, so you don't have to repeatedly type them. For this we use variables. Let's introduce variables. First of all, we introduce numerical variables. The two basic numerical types in Python are int and float. Int for integer variables, float for decimal variables containing decimal places. Why does Python make a distinction? Well, because for Python it's much easier to handle an integer than having to handle a number with decimal digits, because if you write this thing here, Python has to remember only these digits here. If you write this thing here, Python has to remember also all the zeros afterwards. It are handled in a completely different way. Well, you will not notice it. You will probably mix them, because you can multiply an integer by a float and get a float, obviously. Okay, variables are used in this way. An expression can be a variable also now. So we add to the grammar before here that an expression not only can be a number, but can be also a variable. It means that I can put inside this calculation also a variable. What is a variable? A variable is any name starting with a letter and containing letters, numbers, or underscore. So variables are just names, like the variables used in mathematics. Okay. The difference is that in mathematics you can imagine that a variable corresponds to a number. Here, the variable does correspond to a number because there is a little space in the computer memory which is reserved for the value of that variable, and there is something written inside. So while in mathematics you have to imagine that the variable corresponds to a number, here it does really correspond to a number. Okay? The name of the variable must start with a letter and can contain letters, numbers, and underscore. How do you put the value inside a variable? Well, we have a new type of statement. Until now, the only statement we had was the print. Here we have a new type of statement, which is variable equal expression. Pay attention that this one doesn't have anything to do with mathematics instead. This one means calculate the expression here, whatever it is, and the result goes into this variable here. You cannot put an expression on the left side. Okay, let's make some examples. A equals 7. I am putting inside variable a 7. Let's see. Print a 7. B equal 7 plus 3 divided by 2 dot. Print b. Okay. Notice that a is an integer variable, b is a float now. C equal a plus b minus 1. Print c. Okay, so you can, this is an expression. This is an expression, this is an expression. I can print c plus a minus 1 also. This is an expression. Okay. In particular, it may be convenient to rewrite the previous calculations that we did here, this one, Previously we calculated this one. Okay, it's much more convenient to write it like this. Speed of light equal first statement centimeters cm per meter equal 100, then gigahertz of my computer equal 1.3, and cycles per gigahertz equal 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and now I can write all this thing as speed of light by centimeter per meter by my gigahertz by cycles per hertz. There's a mistake here. Okay. Different result. I'm sure I forgot. Yes, I forgot a 0 here. Okay. What is the advantage of doing like this? Well, first of all, if you forget a 0, you just fix it here. Suppose I change computer, I get a faster one. I just change the number here. Okay. First, second, it's much clearer. If you look at the formula here, you don't understand a thing. If you look at the formula here, you are starting to understand something. There is no reason to write the variable names in the way I write them. So with a capital letter and another capital letter to separate the words. There are people writing them in this way. Okay, so write as you wish. The important thing is that I understand them. So if you use, for example, sol, speed of light, it will be difficult for me to understand that thing is the speed of light. Okay, so please try to write them meaningful. Okay, some people write speed. Sometimes I find things like that. I have to guess it's speed of light. Okay. Okay. Overwriting variables. You are free to do something like this. Seven, 5. Can you see? So you can rewrite the same variable, but the value will change. Will change, however, not retroactively. Will change only from that moment onwards. Okay, something which students have a difficulty in grasping it. So overwriting a variable will not change the previous value, so you will still see 7 here, because A is 7, then you print A is 5, then you print A. Okay, so you still see 7 as the first printing, you don't change it retroactively. So things which are already done are done. So if now I change cycles per hertz, or I change my gigahertz, this number will not change, unless I re-execute this command here, this statement here, but I do not execute this. So if now I change gigahertz to 1.5, okay, now gigahertz is 1.5, and if I re-execute this statement here, you will see a different number. If, however, I re-execute everything, well, gigahertz will go back to 1.8. Okay. Okay. Another thing which students find even more difficult is this one, overwriting variables with a value from the same variable. Because up to here everything is very similar to mathematics, and even though probably you disliked it forever, well, it's something which you are familiar with. Now there is something which is typical of computer science programming. It's the following: a equal to 5, print a just to check. Then look, a equal to a plus 3. A is 5, I print a is 5. Then look at this one, a it's equal to a plus 3. What does it mean? Well, is it legal? Well, let's look here at the grammar. We say that a variable is an expression. I said it here. Variable is an expression, so a operator plus 3. It's an expression. So a plus 3 is a perfectly legal expression, and this thing here, it's variable equal to expression, which is perfectly legal, as you see here. Where is it? Variable equal to expression. It's a perfectly legal statement. So this is perfectly legal. And the meaning is, take the current value of a, add 3, and put the result into a. Okay. So first you evaluate the right side, and then you put the result into the left side. It's important to note that in computer science the equal does not mean equality as in mathematics, otherwise this one will be wrong. It means something different. It means take what you find on the right and put it on the left. Okay? Something which didn't have serious problem dealing with. But unfortunately for you, this instruction in particular is very common because it's an instruction with which computers typically count things. So the increment of 1, it's very common, this instruction, and you will find it a lot of times. So remember, the equal doesn't mean being equal, means take what you have on the right and put it on the left. Let's see, what is the value of hours after running these statements? Please don't copy and paste. Now stop the video and try to do it alone, thinking, not copying. Did you stop it? Okay, let's do it together. Hours equal 9. Then I have hours plus 1, which is 10, and I put the result into hours. So now hours is equal to 10. Multiplied by 2 makes 20. And now hours is equal to 20. So hours, hours is equal to 20 after running these statements. What is the value of minutes after running these statements? Stop the video and think. Okay, let's see. They are identical to these ones with one exception. You don't specify the value of minutes. So what will happen? The statements are perfectly legal. However, the computer will see this one, will try to calculate minutes plus 1, will go searching for a variable called minutes. There is no variable called minutes because it has never been assigned, so there is no space in the memory called minutes, and we say, well, I'm sorry. Let's see. I'm sorry. No way. Name minutes is not defined. So you never assign a value, and Python refuses to do something with it. There are other programming languages which are not so kind. Other programming languages, if you use a variable which has never been assigned a value, you will either get a random value, really a random value, or get 0. Python is very kind, it tells you you have never defined it. Okay, print the number of days that you have been alive using as many variables as possible. Try to do it alone. Stop the video and try to do it alone. Okay, together. Okay, so first of all, my age in years. I bet you know it. My age in years. It's 34. Well, I'm almost 35, so 34.7, let's say. Then how many days are there in a year? So days per year. It's 365.25. Now I could print the result, which is the multiplication of these two, but since I want to use as many variables as possible, my age in days is age in years by days per. The spaces that I'm putting here, here, and here, and here are not necessary. I'm putting them only for your readability. And finally, print age in days. 12,000. Okay. Oh, it's not perfect because this one is not really 0.25 and this one is not really 0.7. A much better calculation will be done using the exact dates, my birthday, etc., etc. But it's just a rough calculation. Comment. Sometimes you want to put comments. Why should you put comments? Well, for two reasons. Because other people like me, for example, may have to read your code, or yourself will have to read your code later on after some months, and you won't understand anything. So how do you put a comment? You put this symbol here, and you say this. How you put a comment? This number is not exact. Okay. 0.25 for leap years. Everything after this symbol here, it's ignored by the interpreter. So when the interpreter will execute these commands, we'll say this one fine, and then ignore this symbol and everything after. Okay. You can print also. You can put also commands which use an entire line. Comment which uses an entire line. Okay. In this case, the entire line will be ignored. Can you see? Results still the same. Okay. Until now we have seen the numeric variables. There exist also text variables. They are called strings, str. Okay. Text variables have a different way of assigning, while where is it? This was the assignment for numerical variable equal to expression. Text variables are typically assigned in this way. Same way, variable equal to expression, but expression in this case it's quotation, a string quotation, or double quotation, or single quotation, a string, single quotation. Don't mix the two. And what is a string? A string is any characters. It may be 0, 1, 100,000. Okay? Let's see some examples. Print hello. Print hello. Hello true. Okay? Let's see. Hello true. So this is an expression. This is also an expression. You can also store them in a variable s equal hello, and then print s. Hello. Okay. Why do we have two types of string delimiter? Well, some programming languages use quotation, some use double quotation, some use quotation for characters and double quotation for text. So Python's decided, okay, let's take both, and that's over. Okay, so this is the reason why we have both. There is an advantage in having both, is the following. Let me do B. Okay, it's the following. This isn't an easy sentence. Okay, can you see here? I need the apostrophe inside the sentence. If I use it also as a delimiter, Python will get confused. So in this case, I must use the double quotation, and I can use the apostrophe in the middle. Wait. Look here, same thing. I needed a double quotation inside the sentence, so I can use the apostrophe as delimiter. Okay. And what if I have to use both? So if you are so unlucky that you have to use both, well, let's use the double quotation. This is. You must suppose you want to put a quotation here. Okay, if you do something like this, Python will believe that this were a string, this were nothing allowed by the grammar, so syntax error, and this were a string. So we have to use the backslash to protect it. On the German keyboard, Alt-Shift-7. Okay. So if you use the backslash, you somehow, we say in computer, you protect the quotation. So Python will take these two things as the literal double quotation. And can you see? Okay. With strings, you can, officially, according to our grammar, since strings are expression, you can do expression operator expression. So plus, multiplication. Yes, in theory you can, but not always you get a correct result. The things that you can do are string plus string and string by number. You cannot do string by string. I don't see any meaning. Or string minus string, string divided by string. Okay. Or string. You cannot even do string plus number. If you do string plus number, you don't stick them together. It gives you an error. So let's see. Print hello plus bye. Result is hello bye. So put them together. If you want, you can put a space in the middle. Hello bye. Okay, it is the meaning of print Paolo by 20. Paolo 20 times. Easy, no? And if you want to put a space here, Paolo. Okay, so this is the meaning of multiplication. Look that you cannot do print Paolo plus 7. This will not produce Paolo 7. Will give you an error. You see? Cannot concatenate string and int objects. I know it would be easy to join them together. In fact, there is the trick, which is the following. Okay, now it works, but I reserved the trick for the last exercise. Okay. String have also another feature. You can index them. Suppose you have a string, for example, s equal this is a long sentence, and you want to get the third character. Okay. To get the third character, use the square bracket 3. No, I'm sorry. If you use square bracket 3 in Python, you get the fourth character. S, this one. Because Python, remember, Python always starts counting from 0, as any computer scientist. So in computer scientists start counting from 0. So this is 0, 1, 2, index 3, S. Okay. So you can extract a single character from a string variable. The syntax is this one: variable, square bracket, the index, square bracket. Works only for string variables for now. Gives us the character in position number, where 0 is the first position. And it gives you a string, So the result is a string. So this one is a string of length 1. What happens if you exceed? So type, you don't have 98 characters. Error, as usual. String index out of range. And what happens if you put 0 is the first one? What happens if you put a negative number? It starts counting from the end. So this is minus 1 and this is minus 2. Pay attention, because this is 0 and this is 1. But this is not 0. This is minus 1. This is minus 2. So you get to see. Okay? So easy. Sometimes, however, that's even not enough. Sometimes you want more than one character. Okay, in theory, if you want, for example, the first 3, you could do something like this, but it's very inconvenient, especially if I ask you the first 20. Okay, so how to get the first 3 without having to do something like this? Well, the trick is the following. Using the colon here. Look at the Bakus-Naur format. Unfortunately for you, the course is called Algorithmic Thinking and not learning how to programming and becoming a nerd. And therefore I have to make some theory, because you have to know how does a computer think. So here the theory. So variable, open square bracket, close square brackets, number, colon number. This gives us the characters from position number to the position, and pay attention, before the second number. So not from number to number, but before. Let's see. I copy this one. I don't need to copy it because S is already this one in the computer memory, but just to make you see. Okay, now S. Okay, now 0, 1, 2. So I, 3, S. Sorry, let's say 6. 3, S. Space is the fourth. I is the fifth, and it will not display S, which is the sixth. So it will display only this thing. Let's see. Print. Can you see? Because remember, starts from the second one. Remember that Python starts from 0. So 0, 1, 2, 3, so 2, 3, 4, 5, and stops at the character before the sixth one. Okay? Easy. And what if I write negative numbers? Well, for example, look at this one. Starts on the second one, which is I, and stops at the third last character, which is this N, or better, before the third last character. So we'll display all this thing here. See? Okay, so starts at the second one, so 0, 1, 2, and goes up to the character before the third last. The third last is the N, the character before is the E. Please note that in some cases, for example, this one, for example, nothing is produced because starts from the third one and stops at the character before the third one. So nothing is produced. Also in this case, nothing is produced. Okay, also in this case, nothing is produced, I think. No. In this case, nothing is produced. Okay, this case. Okay, so if this character is after this one, it's before or equal to this one, nothing is produced. So not really nothing, an empty string is produced. Still a string. It's not enough. Sometimes you can be lazy and omit these things. What happens if you omit them? Well, if you omit the first, you mean automatically it's at 0. If you omit the last, automatically it's the character after the end, so it goes up to the end. If you omit both, it's the entire sentence. So both from the fifth to the end, from the beginning till the sixth, till the character before the sixth. So, okay, easy. Okay, some exercises. Starting from a variable containing unibz, print uni bz ib. Obviously not like this. Do it like this and you will receive 0. Okay, stop the video and do the exercise. Okay, now uni, so 0, or better, I can omit it, it's 0. 4, wait. This is 0, this is 1, this is 2, so if I have to type here 3. Yes, uni. Bz, I start from 0, 1, 2, 3, and I go up to the end. Okay. IB, 0, 1, 2, and B, I have just -1, I think it's enough. IB. Instead of -1, you can type 0, 1, 2, 3, 4. Okay. Choose any long string and put it in variable s. Without trying, tell the result of this thing here. Well, let's take a long string. Well, look, I'm particularly lazy today. Okay, this is the alphabet. At high school, I had one of my mates at high school, and they did a language high school. One of my mates didn't know the alphabet, so didn't know the sequence of the letters. So if you don't know, now you know. Okay, now S colon. Well, S colon is the entire string, no doubt. S plus S 0 colon minus 1 plus 1. Okay, let's see. This one makes 0. 0 colon 0. We said before that S, a number colon the same number, it's an empty string. So this is empty. So it's S. Okay. S 0 colon is still S. Because start from 0. S colon minus 1, I think it's everything up to the letter before the last one, so up to Y. S colon 3, it's everything up to the third one, so 0, 1, 2, okay. And S3 colon is everything starting from the third, so 0, 1, 2, from D. Okay, so the entire S again. So all of them are S except this one. Let's try, because... print. Always, I know that if you don't specify print, sometimes it prints anyway. So it's, but not always. As you can see here, it printed only the last one, didn't print the other one. So always use prints. Oh yes, all of them are S except this one. And if S is empty, okay, also this one in this case is S. Okay. Now let's see how to find a string in another string. So what's the problem? You have a long text and you put it inside a string variable, and you need to find the position of a word, for example, but also anything else is fine, a character, a sequence of words, in this long text. The command is this, the statement is this one. Okay. You write here the variable in which you have the long text. In theory you can write here also the expression, but I will see it very rarely. Then you write dot, literally dot, find, open parentheses, and the expression that you need to find. Usually this one is just a string of text, but you can write also complex expressions. The result is a number, so it will give you a number. So it seems strange, but number is also this thing here. The result is a number, which is the position of this expression in the text inside the variable. If the expression is not present, it will return -1. Let's make an example. So s equal this is a long sentence. Okay, so print s dot find, for example, I 2. So is it in position 2, position 0, position 1, position 2? It gives the position of the first occurrence. So long 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th. Okay, and if I say longer, -1, it's not here. So pretty easy. Okay, and what if you want to find, for example, this S here and not this one? Because if I search for S, I find 3, which is this one. Okay, Sorry, before talking about it, I have to talk about something else. Okay, so this is the first time you see something which starts with a dot. Things which start with a dot are called method. Okay, each type, so int, until now we've seen integer, floating, so int, float, and strings. Okay, has several methods. So several, let's say, commands which can be appended to the variable using the dot in this way. See? Okay. The Bakus-Naur notation for methods is the following: variable, dot, name of the method, any number of expressions separated by commas. Okay. It will give you usually an expression, in this case in particular a number, but can give you something else. Okay. The only thing we have seen until now is dot find, but there are several other methods. We will see very few of them, okay, because they are pretty technical. Let's see some exercise on find. Which of the following has always a value of 0, regardless of the value of s? So it doesn't matter which value s has a string. Let's see, regardless of the text value of s. Okay, so stop the video and try to do it alone. So now I assume that you have done it alone. Let's see. S find S. This searches for the string S inside S. Well, it will find at position 0, obviously. So this is a result of 0. S find the text S. This searches for the character S in string S. Well, it depends where it is. So usually it doesn't have a value of 0. This one, look, it searches for the character S inside a string which is composed only of the character S. So it will find it at the very beginning, so position 0. This is the strangest of them all. It searches for nothing, so for the empty string, in a text variable S. Seems strange, but the empty string is always present everywhere. Well, it's nothing, so it's present everywhere. I know that it's philosophical, okay, but nothing is present everywhere. Okay. So it will find it in position 0. Let's test it. 0. So, seems strange, but nothing is always present in any string at position 0. Let's see this one. It searches for the string S itself, concatenated with blah blah blah, okay, in the string S. Obviously, this is not present in the string S, because it's even longer than the string S itself. So the result here will be -1, plus 1 makes 0. If you don't believe me, sorry, print. Always use print, otherwise it prints just the last one. Okay, now as I was anticipating before, you would like to find the second S, or even the third one. Okay, the find until now gives you just the first one. You can find a string in another string after a given position. The Bakus-Naur syntax is the same, but the difference is that here you have a second parameter. These things here are called parameter. Okay. They are called parameter when written in the theoretical form. When you actually use them, like here, so when you actually use them, they are called arguments. So there is a little technical difference. This is the argument, and this is the parameter. So parameter, whenever you talk about the function itself, when you really use it, it's called argument. So S is the argument, the expression is a parameter. Okay, so find the ones two parameters separated by a comma. Okay, so let's see. S equal to be or not to be. Okay, S dot find. If I search B to B, result will be 0. But if I search to B starting from position 3, so 0, 1, 2, 3. So starting from this B, okay, it will go on, and will find this one, 13. Okay, so pay attention that even if I start from position 3, let's say I start from position 13, it doesn't give me 0, it gives me still 13. So I search for to be starting from here, doesn't give me 0. It's still the index is referred to the entire string. And now difficult exercises These were really difficult. I made a mistake in one of them. So, stop the video, try to do it alone. Okay, now, imagine you have a string S. Let's use this one. You are supposed to do this one. Okay. Where T is something, for example, to be, and I is something, for example, 3. Okay. So print here. Okay. This case it gives me 13. Okay. I am asking you whether this one is equivalent. Let's see. This one, first of all, considers the string but starting from I, so this part of the string. Okay. And searches for T. Apparently it may seem the same as this one. This one searches for T starting from here. The difference is that this one searches for T starting from here, but the string in this case starts here. So the result will not be 13, the result will be 0. Sorry, it will be 10. Can you see? It's 10. Because since you restrict the string starting from here, this T here is now in position 10. Okay. So even though they search for the very same thing in the same thing in the same string, okay, this one considers the entire string S. This considers the string reduced. Okay. Let's do this one instead. It searches for T in the string S, so the result is a number, and then it applies the square brackets to a number. Well, until now, we have never applied square brackets to a number. In fact, it's illegal. Okay. If you search above for the Bakus-Naur format, where is it? Okay. You see, I write here, works only for string variables for now. Later on it will work also for other variables, but for now it works only for string variables, so you cannot do something like this to a number. Even worse, to an expression. You see, until now I have defined it only for a variable. So this thing here, applying the square brackets to an expression here, it is an expression. Well, in general it's a number, because find gives back a number. It doesn't have any meaning. In fact, if you try to do it, it will give you an error. Let's do this one. This one is the same as this one, but adds I, which may be good. Let's see. It searches for to be in this reduced string, finds it here, gives you 10, which is the index of to be in this part of the string, and then adds I, which in this case is 1, 2, 3. Result is 13. So this one, if we try it, gives us the very same, okay, can you see, 13, gives us the correct result, because it still considers only the reduced string, but then it adds the number of the index which was missing. Let's say this one. This one searches in the reduced string, so only here, searches for, well, for a reduced T. It doesn't make any sense. Okay, it works. It will give an error, I think, because no, 0. Look, T of I, 3, 1, 2, 0, 1, 2, 0, 1, 2, 3. So 3 is, this one is B, searches for B in the reduced string, gives you 0 because it finds this B, but finds something else. So this has nothing to do. Okay, a little addendum to the video. Sorry if I do it at the end. Okay, first of all, whenever you print, you can print more than one thing at the same time. So for example, print 57 by 8, comma, I leave some space just to improve your readability, but you can skip them. 4.5 plus 3, comma, 7. Okay, and this will print all the three things with a space in the middle. So print with a comma leaves a space in the middle. If you're using Python 3, you should put it like this. If you're using Python02, instead doing like this produces extra parentheses which are not what you want. So if you're using Python02, Don't put the parentheses at all. So putting the comma print several things at the same time, leaving a space. We will see later on that putting the comma, it's written here, will also have some other advantages. Okay, then another thing, where is it? There's comments. Okay. If the line is too long and you prefer to split it, you can use this symbol here. Well, now the line will never be too long, but imagine you have an extra long line because complex instruction. Let's make an example. Print 7 plus 5 by open parenthesis 23 divided by 4. Okay, now this is fine. Suppose that this line is too long, doesn't fit into your screen. You can interrupt it at any time. Put this symbol here, which on a German keyboard, it's on the Mac, is produced with Alt-Shift-7. Okay, and then you can go to a new line. You see, the result is exactly the same. So this means go to the new line. Otherwise, you're not allowed to go to a new line. If you do like this, invalid syntax. So with this symbol, it means continue on to a new line. You can also, to improve readability, make it like this. Okay. Okay, finally, types. Okay. We have a function in Python which tells us which type is a variable. Well, now in this stupid example, it's not necessary to use this function, but later on, you will see that it may be useful. So, the function is type. So, for example, a equal 12, type a int. Okay, if you prefer print type a, will tell you that int is not text but it's a type. Doesn't matter too much. You can just like this int. Okay, so if you decide 12.5 now float, if you write blah 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 star. Okay, well, now as I told you, it's not necessary, but later on we'll ask variables to the user and we will be interested in checking whether the variable is an int, a float, or a string. We have also variable function float, int, str, which convert a variable to a respective type. For example, now a is an int. Okay, if I write like this, you will not notice any difference. Okay, no, you will not see a difference. It's a float now. Now it's a string. Okay, you don't see it, but if you ask the type of str a, it will tell you it's a string. Okay, so str converts it into a string and float converts into a float. Okay, same thing for this is now a float. Int converts into an integer and obviously will cut the digit after the comma, and str will convert it into a string and you won't notice it. Okay, finally, pay attention that this one, it's a string. It's not. Now it becomes a float. It means that you can do mathematical operation. Otherwise you can't, because if you do like this, can you see it's not what you want. If you instead use float a, now you convert a into float, you multiply it by 5, this is what you want. And int gives you an error because this cannot be converted into an integer. So if you choose int, it does not convert a float and then convert into int. It can't be. Same thing if you use blah blah blah. This also gives you an error because there is no way to convert blah 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 into a float. Okay, there are other useful operators and functions which I want to talk about. This one is the symbol of the remainder of the division. Do you remember the division at elementary school? At elementary school, 17, so let's make an easier example. 7 divided by 3, the result was 2 with a remainder of 1. Okay. Print 7. So if you write print 7 divided by 2, Python will give you 3. I tell you, Python version 3 will give you 3.5. Okay. If you instead write 7 %2, it's the remainder of the division, in this case 1. Let's make some other example. 15 divided by 5 will give you 0, obviously, but 19 divided by 5 will give you 4. It's the remainder of the division. Why can it be useful? Well, it can be useful, for example, to check whether a number is even or odd, because an even number will give you a remainder of 0, and an odd number will give you always a remainder of 1. Then this one is the symbol of power. Oops. Okay, don't use this one. The same as pow function, for example, print 2 to the power of 3, result is 8. Same thing, print pow 2, 3, result is 8. Okay. Now, other useful function, max, min, round, and leng. I don't want to offend your intelligence making examples, but I have to make them by contract. For -3, 5.39, max is 9, the mean is -3, I guess. Okay. Then round, 56 point some digits, comma 3. This will round to the third digit, so up to 4. If this one were 5, it will round, this one will become 5. Let's see. Yes, can you see? It follows the mathematical rules for rounding. And len is the length of a string. 6. It works, all these things works obviously also with variables, 4. Okay, goodbye.